So we're asked to put this in terms of secant, and the reciprocal of secant is cosine. And so actually, if you graph a cosine graph, it should fit right in between these two things, like this. Because cosine makes that classic sine wave, right? So if we can find the equation of this cosine graph, all we have to do is switch cosine and secant, and then we're done. We have the correct graph. So we're trying to figure out what's going on here in red. So like we did last week, imagine cosine of x before we start messing with it, before we start moving around. The graph looks like this. It starts at the peak of the amplitude, goes to the bottom, and then comes back to the top. Right, so this cosine graph, it looks like it might start at the peak, but we don't know this exact coordinate. My graph's a little off. It should have touched right here, but we don't have this coordinate. We do have this coordinate, though. So if we think about negative cosine of x, that might help us. That starts at the bottom, and then to the top, and then to the bottom. It's just got some sort of phase shift happening. Okay, so we're going to want to consider negative cosine of x. But I think that we might be a little ahead of ourselves there. Or I am a little ahead of myself there. Let's start with the easy stuff first. Let's find d. We're looking for this. Y equals a cosine b plus bx plus c over d over b plus d. Same type of thing. We're looking for this same type of structure except cosine. So d is the vertical shift. It's the equation of the midline. And so for the red graph that I have here for cosine of x, you can, if you check out the coordinates, the midline is at 1. So far I know that d equals 1. And then the amplitude is just the distance from the midline to the peak of the amplitude to the peak of the graph. So there's a distance of 3 there. So a is going to be 3. We'll want to consider negative 3 as an option too. And actually, I think we have to. There's no other way to get around that because we only have this coordinate. You know, if we're going down, we need to make a phase shift. So we got to let a be negative 3 and then consider what's happening. The problem is there's so many different ways of doing it. Like cosine, you can shift it 360 degrees, and you can still have the same graph. There's lots of different ways of writing the red graph that we have here. But because of the coordinates we have, we've got to consider this shifting this type of function starting down here. Again, we're focusing on the red graph. We want to make that, we want to figure out the cosine of that graph, because if we do, then just switch cosine with secant and you've got the blue graph. So let's do the period next. Actually, I was thinking of doing something else, but the period is just the distance until we start repeating ourselves. So it's this x distance. So we just need to take pi over 6, this x coordinate, and subtract it by negative pi over 6. Negative pi over 3 over there. Subtracted by this one. And so if you get common denominators, that's 3 pi over 6, which is pi over 2. So that is our period. And for cosine, to find out what b is, the period equals 2 pi divided by b. We just found out the period. The distance on the x-axis until we start repeating ourselves is pi over 2. So if you solve this equation for b, then you have the period. You'll have b for our graph, which comes from our period. So divide both sides by pi, multiply both sides by b. You get 1/2 b equals 2. In other words, b equals 4. So now we just need to find out what c is, and the phase shift. I don't want blue. The phase shift is just this distance from the origin to our starting point. Okay. You could have done the phase shift by going in the opposite direction if we had a point over here, and then we would use positive 3. But like we said, they only give us this point that's out in front of us, so we got to have our cosine graph starting at the bottom of its amplitude. That's why we let a be negative 3. And so what's this distance? This is pi over 6 on the x-axis. But it's got to be negative, because remember with phase shift, it's in the opposite direction of what we'd usually think. If you want to go pi over 6 units to the right, then your phase shift, this part right here, has to be negative pi over 6. Okay, so I think we have everything. To put it all together, the red graph is y equals -3 cosine our b was 4 x minus pi over 6, or plus negative pi over 6, because this is our phase shift, plus 1. And so our the graph of the blue graph is just going to be replace cosine with secant. Just the reciprocal of the red graph. So the blue equation over here is right if you graph it. I just got to thinking, I don't know if Newton is going to be picky about this. There's nothing to really be picky about, but if it marks the answer wrong, there's another graph for this. You could do the phase shift. Instead of going forward, you could do y equals -3 secant for parentheses x plus pi over 3 plus 1. But these will make the same graph if you graph them in decimal. So it should accept either one of these answers. But just want to make you aware of this other answer, because look, this would be a phase shift if you were to back yourself up pi over 3 units over here.